These are the tech active solutions here. I'm going to be using the Casio FX calculator, and I'm going to be showing you some of the like little tricks that you can use on that calculator to save yourself a bit of time, especially in the multi-choice, because you don't have to show any working out. Now, I do encourage you, like, have a look at the 4 questions that are here, pause it. Again, these are going to take you like 90 seconds each. So the important thing with tech active is just knowing exactly how to navigate your calculator. So pause it, give it a go, and we're going to pretty much start after that. So when we're determining the area enclosed by 2 functions, what you want to do is you want to graph them, and then there is a nice little function in there. So we go to the graph part, so number 5, and I'm going to put in my graphs here. So it's x cos of x. And whenever you're putting in a trig graph, make sure you are in radians. Okay, if you're in degrees, your graph is going to be off. So if you're doing graphing or any calculus on your calculator and you're using trig, you must be in radians. Okay, that's how you want to go about that one. Okay, equals there. And then our other function was x squared. And now we want to graph it. So let's go. So that's what we get there. Now we can zoom this in. Okay, we go shift, zoom, in, and about there. Yes, equals there. Okay. Now what we can do is we go G solve. So 5G solve. You go along, and there's this little integral symbol there for F3, and you go intersect, which is F3 here. And you want to go from this point, go along to your next point. And what's going to be displayed there is the exact area between those 2 curves. We do 0.102. So we go back 0.102, that's closest to 0.1. Next. Normal distribution questions. This is just NCD, where we know that the mean is equal to 10, standard deviation is equal to 5. This is just a matter of knowing where to go on your calculator. So at least on this one, let's go out of the graphing. We're going to go into statistics, and we're going to go distribution, normal, NCD, and we're going to go variable. Our lower was 5, our upper was 11. Our standard, hang on. Upper 11. Standard deviation was 2, and our mean was 5, was it? Not? No, the mean was 10. Let me have a look. Yeah, mean was 10, standard deviation 2, between 5 and 11. Now, if you want to just do a little gut check here, you can go all the way down, and you can click draw, and it'll show you the bell curve there. So that's kind of what we want. Like 10 was the average, 11 is a little bit before that, and then 5 is like well below there. We've got 0.685. So we're going to find that, and that's going to be our answer, B there. Okay, so here you've got a displacement function given by some log, and then determine the acceleration. Now, pretty much what you want to do here is the fact that you've got dVA, okay, which is displacement, and you want to get to acceleration, you need to differentiate twice. I'm not going to differentiate that because that's like chain rule and product rule. And this is tech active, multi-choice. So where's the button on our calculator that's going to do that? We go out of here, go into the run matrix, math, ddx2 for second derivative. Okay, so you go, that is F5, put in your function, and just pretend that t is equal to x. So we had x, and what do we have here? Log base 3 of 2x squared. Okay, here you've got log AB. You can chuck in whatever base you want there. So log with a base of 3, 2x squared. And then outside of that, we also had 1 minus 1 over t. So minus fraction 1 over x. And this was at the point 0.8. 0.8 equals, bang, negative 1.63. Negative 1.63. That is option C. This one's a little tricky, so we've got a study revealing flexibility shows that p hat is equal to 0.18. Okay, only 18% of people can touch their toes. With a margin of error of 3%, so 0.035, and a 98% confidence. So if we remember, our margin of error formula is the z-score times by the standard deviation, p hat, outside of 1 minus p hat, over n. And we want to determine what is this n closest to. Okay, now I've actually got this solution here should be n equals 652, not 655. Kind of giving away the correct answer there. Now, this is a little tricky because you've got 98% confidence. So you can't just say Z is equal to 1.96 because that implies 95% confidence. So we need to find the particular Z score that is appropriate for 98% confidence before we go ahead and plug in anything here. So let's do that. And the way that I'm going to do that, again, I go to my calculator and I'm going to be going in the statistics menu and I'm going to normalize this data and looking for a Z score as inverse Z. Now here I've got a central area, and the area is 0.98, okay, for 98% confidence under this bell curve. And again, I'm going to normalize it, so the standard deviation is 1, the mean 0, and that'll give me my Z score. So 2.3263. 2.3263. So now what I'm going to do is error is equal to 0.035, that's equal to 2.3263 outside of 0.18 times by 0.82 over n. I'm going to solve n this because I cannot be bothered to try and solve that by hand because I have a graphics calculator and that's going to do a whole bunch of solving equations for me. So I go here into my run matrix, I go options, calc, solve n, and this is like a numerically solving the equation, and I just put in my equation 0.035 equals, so shift equals, and what was it, 2.32, I guess that'll approximate it, and not there, enough, 63, okay, 63, standard and then multiplied by my standard deviation, which is the square root of 0.18 times 0.82 divided by x. In this case, that's my n. Now, don't put your bracket here. If you put your bracket there, that's inside the square root. You're going to get a syntax error. So don't do that. Make sure you put your bracket at the very, very end. And we get 652. So that was B, which was the solution I had to fix up because I put the wrong number there. Okay, decibel loudness, it measures some intensity. It can be given by that equation there, where P is the power. And we're saying what's the power going to be when we've got a decibel reading of, so decibel of 88. So I go 88 equals 10 log base 10 of P times by 10 to the power of 16. Now, this, I've deliberately put it in here. It's probably more tech-free because you're not going to use your calculator to solve it, and I'll show you exactly why. If you're going to solve n here, you're going to get the wrong answer. So one of them here is P has no solution. P clearly has a solution. So this cannot be correct. There is no way it's A, but if you just blindly go ahead and put things in your calculator, you go solve n, and you go, what do we have? 88 equals 10 log base 10, so just regular log, x times by 10 to the power of 16. What you're going to get is you're going to get no solution, which is wrong. Okay? So just be wary of solve n. Sometimes it won't exactly give you... Be wary of solve n. That's all I'm trying to say. Okay? It's like awesome 99.99% of the time. Sometimes it'll stuff you up. So just do a little sanity check every time you see an answer. If you get no solution and you look at that, you probably should have the suspicion that it's got a solution. Okay, so if I divided, give me my blue here. If I divided by 10, I get 8.8 equals log base 10 of this stuff here. And then I can apply my log to exponent translation there. So that's 10 to the power of 8.8 equals P times by 10 to the power of 16. Divide by 10 to the power of 16 and you're going to get B, okay, which is 10 to the power of 8.8 divided by 10 to the power of 16. So just be a little bit wary of solve n. BMI 25, over 25 indicates that you are overweight according to their score. It's known that 45% of the population are overweight, so their BMI is over 25. So we know that to be true from a sample of 80. Okay. Determine the probability that P hat equals 0.5. 4, 5. So if you can imagine what's happening here, we know that 45% of the population is overweight. So if you're going to grab someone from the population at random, you know you've got a 45% chance that they're going to be overweight. That tells us that if we took a sample of 80, 80 times by 45%, or 0.45, is going to equal 36. So that means, what's the probability that I'm going to take a sample of 80 people and find out that 36 of them are overweight? This is a binomial probability. So this is BPD. X equals 36, N equals 80, and the probability that they're going to be overweight, picking them at random, is 45% because we know that. So that's what I'm going to put into my calculator. Again, where do you find your binomial stuff? You go into your calculator. Statistics, distribution, binomial, BPD. And we've got 36 out of 80 people. That's what I want to happen. And the probability that they are overweight is 45%. So 8.937%. So that's going to be this one here for A. All right, Pedro plays some tennis on clay, wins 60% of the time. So P is equal to 0.6. During the competition, he plays 10 matches. The probability that he wins at least 7, given that he wins at most 9. So we've got a condition there. I don't care about the case where he wins all 10, so we're going to remove that from our sample space. So essentially what that means is the probability that he wins at least 7, so that's winning 7, 8, 9, or 10, but you don't care about winning 10, so the probability that he wins 7, 8, or 9, given that he wins at most 9. So what this is looking like here, oh, I better clean up my notation here, given that X is less than equal to 9. So that's going to be the probability that he gets between 7 and 9 out of the fact that he gets less than 9. So this is a conditional probability where we are reducing our sample size, and if you're selecting from out of that sample size, you've got to remove it. Okay, that's our conditional probability. So this is like two probabilities, like a probability divided by another probability. So what we're going to do here is I'm selecting probabilities of binomials between ranges, so at least on this calculator, distribution, binomial, BCD. And I can say I want to have 7 wins, 8 or 9 wins, so 7 to 9, where I'm playing 10 matches. The probability that I win is 0.6. That's going to give me 0.3762. So that's 0.3762 divided by the fact that he's going to win at most 9. So if he wants to win at most 9, that is changing this lower to be 0 instead of 7, because like he can win 2 games because that's at most 9. He can win 4. Like doesn't matter. 0 to 9. That's the range I'm looking for. So it equals 0.9939. 0.9939, and then I'm going to put this expression here into my calculator, and I'm going to get what it's closest to here. So go chuck it as a fraction. So that was 0.3 what? 762. 3762 divided by 0.99, was it? Whoop, not that. 39. 0.3785. 0.3785, that is going to be D there. 3 more questions here. In the multi-choice, I've got a triangle where we've got A, C, and B. A has an angle of 40 degrees. C has an angle of 115 degrees. C, length there, 24 meters. What's A going to be? This is just an application of the sine rule. So sine of 40 divided by A, or in this case X, equals sine of 115 divided by a 24. And I'm going to put this in my, like again, this is solve n here. And just be careful now, because most of the time you're in radians. Here you're dealing with degrees, so just do a quick change to degrees whenever you're doing this stuff here. So radians up there, so I'll just go Shift, Setup, change it to degrees there. Yes, degrees, thank you very much. And then Options, Calc, Solve N, and then put in my sine rule stuff. So sine of 40 over x equals sine of 115 over 40. Sorry, 24. 22.4. Close that off there. 17.02. 17.02. Now, like, you could look at this and just rule off A and B, because like the answer has to be less than 24. So you pretty much, like, if you got A and B, it's like, okay, maybe I've stuffed up something wrong with the calculator. So always just do a little sanity check. Question 9, acceleration of a straight line is moving and its acceleration is modeled by this. Determine the displacement time graph. This is actually a little bit tricky. Okay, you got to problem solve this. Like, there's nothing in your graphics calculator that says, oh, here's a function, show me the graph if you integrated this function twice. There's nothing like that. So you've got to do a little bit of interpreting here. Okay, you've got to understand that if you want to get back to velocity from displacement from acceleration, you need to integrate twice. So then you've got to understand the fact that the y values on this function here, those y values, tell you the concavity on the displacement function. So what you want to do is you want to go into your graphing, graph that guy there, and have a look at matching up between A, B, C, and D here, which one, like, where the concavity matches up. So I'm going to go ahead and graph this one here. Delete that. Again, you can see, like, you've just got to be so fast with the calculator. I feel like I'm doing this slow. Okay, so we had 10e to the negative x. 10e to the negative x outside of x minus 2, was it? X minus 2. Just see if we got that right. Yes. Okay, so these, again, I'm going to graph this, draw it. Okay, that's not a good view window, so Shift View Window and just go Initial. Just see if that's going to fix much up for you. Execute there. Okay, that's nice. So we'll just go along a little bit. We don't have to be perfect. So these y values tell us the concavity. So here I can see I'm going to have a point of inflection at x equals 2, and I'm going to have negative concavity before that and positive concavity after that. Okay, so point of inflection at x equals 2. So you just go through. Here at x equals 2, there's no point of inflection. It keeps decreasing. So definitely not this one here. Here, x equals 2 is a minimum. That's not a point of inflection, so you can rule this one off. Same here, it decreases, decreases, so you can rule this one off. Here at x equals 2, it looks like there was negative concavity, and now there is positive concavity there. So I would be going with B as my answer. Okay, question 10. You've got a tee. There is a hole 160 away. Player strikes the ball 150 meters. Let's say they just like hit it here at point A, and then they wedge it in, and they struck at 150 meters there, and then they wedge it in, and that covered 35 meters. Woohoo, right? So they go drive 150, wedge it 30. What's the angle that they were off their initial shot? So here, I'm going to stay in degrees because all my answers are in degrees there. And I'm just going to solve n this. This is just the cosine rule. So I'd say 35 squared equals 160 squared plus 150 squared. Subtract 2 outside of 160, outside of 150, cos of theta. Double check that I'm in degrees. I'm just going to solve n this. Okay, because I'm not going to solve this algebraically. It would just take too long. So go out, run matrix, math, not math, options, calc, solve n, And we had 35 squared equals 160 squared plus 150 squared. Subtract 2 outside of 160 outside of 150, cos, double check, I am in degrees, very good, of x equals, wait for it to do its thing. Okay, so I've got a whole bunch of answers here. We want the one that has an acute angle, so just go along over and over until you get the one that's acute. So you've got 12.43 is what we're probably looking for. So it is C there. That's our multi-choice. Short response, tech active. Question 11, this one is simple and a little bit of complex sprinkled in there. That's part D. With about 7 marks. Take about 10 minutes, pause it, see if you can do it. Right. Survey, 73 tree loppers conducted to identify if the workplace is dangerous. 24 said they have suffered a serious injury requiring surgery. So that would be dangerous. So state the sample of tree loppers who have suffered a serious injury. 24 out of 73. Okay, that was from our survey. 73 surveyed, 24 have had a severe injury. State if the sample size is large enough. So dependent on, pretty much the answer here is yes, it is large enough. Okay, 73 is sufficient. However, you've got to do a little double check here. NP has to be greater than 10 and NQ has to be greater than 10. Okay, we can satisfy both of those because we've got 73 times by 24 on 73. That's going to be greater than 10 because that's going to be equal to 24. Yeah, 24. And then same for the other one. Okay, that's also going to be greater than 10. So yes, again, like that's one mark there. Determine the proportion of tree loppers who have suffered a serious injury with 99% confidence. So what we're going to do here is probably worth 2 marks. One of them is going to be for your expression and one of them is going to be for your answer. So we're going to write an expression here. So I would say that my confidence interval is equal to, and using my calculator, it's going to be one prop where I've got the confidence level, so C level equals 0.99, X equals 24, N equals 73. Okay, because I want to know with 99% confidence what's happening there. So go to our graphics calculator. This is where we're going to find this nice little button here. We go menu, statistics, intra, I don't know what it stands for, Z scores, and we are dealing with one proportion, or like a proportion of one variable, where our C level is confidence level, 99%. We had 24 from 73 tree loppers getting injured. So I'd say 0.1871. So 99, wrong color. 99% confidence interval is equal to 0.1871, 0.4703. Okay, that is my 99% confidence. Now, you're probably looking and go, that is a really large range. That's because we're 99% confident. So if you want to reduce that range, you can reduce the level of confidence. Okay, now assuming the same sample proportion, so p hat equals 24 over 73, determine the sample size required, so n equals what, to have an error of 0.01%. However, we don't want 99% confidence, we want 80% confidence. Again, error is equal to the z-score times by the standard deviation, which is p hat times by 1 minus p hat over n. So in this case, we're just going to fill this out and we're going to use a bit of solve n to help us out here. So I would say 0.01 equals, and I've got to get the z-score here. So just on the side, I'll say z is equal to inverse normal. And what we're dealing with here is 80% confidence. So I want to standardize that score. So I'll go out here. This is a distribution, normal, inverse normal, where I'm dealing with a central area, but 0.8. Okay, again, 1 is my standard deviation and 0 is my mean because I want this to be a z-score. And so I've got 1.2816. 1.2816. Okay, and what I did was, what did I put in the calculator? I better put my expression there because it is short response. Tail is central, area is 0.8. So tail equals central, area equals 0.8. The mean was 0, the standard deviation was 1. Okay, so that means that's going to be my z-score here. Okay, and right here, I'm going to go for a bit of solve and action happening. What you're going to get here is you're going to get a mark for writing the correct expression. You're going to get a mark for generating the correct z-score. And then you're going to get another mark for getting a correct solution. So I'm just going to let solve and do all of my heavy lifting. So options, calc, solve, and we saw this about 1,000 times in multi-choice, where I've got 0.01 equals 1.2816 times for the standard deviation of, I'm going to put brackets here, we've got 24 over 73, and we're going to multiply that by 73 minus 24 over 73. All that's over our sample size, which is x. Uh, 3,625. That's what we're going to need. So n roughly equals 3,624.6. 3,624.6. Therefore, need 3,625 as sample size. Very good. Next question. So this one's simple, familiar. 6 marks, probably about 8 minutes, just because you've got a bit of fluffing around to do here with your calculator. Pause it, give it a go. Should be fairly straightforward. So we've got the weight of a substance remaining after t months. So t is given in months. Is given by some form there. You can think of that as like a function, if you wish. Where initially there was 9,500 kilos of this stuff. After 3 months, the rate was decreasing by -0.5 a kilo per month. Right, there's a bit of information here. Now what we've got here is we've got W of t equals a e to the negative kt. So I can work out initially, because that implies when t is equal to 0, W of 0 is equal to 9,500. So 9,500 equals a e to the negative k times by t, where t is 0, it's just going to be 0. So therefore a equals 9,500. Very nice there. Answer for A. Now we're given that there's a rate. So we've got a function here is 9,500 e to the negative kt. That's our function. Now we're told that the rate is decreasing at this particular value. So we need to say rate implies derivative. Because we're dealing with rate, we're interpreting the question, we're making it very clear that we're going to differentiate, because that is the skill we need to do in order to answer this question. So derivative of this function is negative 9,500 k e to the negative kt. That's what we want it coming out there. And we're told that the derivative at 3 is equal to negative 0.5. So we've got negative 0.5 equals negative that k e to the negative kt. Oh no, not t. Times by 3. Because t is equal to 3. Solve n. Okay, so we get 2 solutions here. So we get 0.00005 So K equals 0.00005 and K equals 3.72. Okay, so in this case, you're probably going to accept a solution and you're going to reject a solution. Okay, now reading on from this is the piece of information that's going to help us accept and reject. So it says, given that the half-life occurs during the first month. So that means half-life means that the weight of it is going to be halved by the time when t is equal to 1. So let's, when t equals 1, and if that's less than 9,500, then that's the solution we're going for. So we've got our value for A, and we just need to work out for K equals 0.00005. So that means W of 1 is equal to 9500 e to the negative 0.00005 times by t. T is 1, and that's roughly going to equal something here. Okay, definitely not going to be the answer. That rate of decay is way too slow in order for that to be the half-life. See, it's like roughly that. So therefore, reject K equals 0.00005. And we're just going to verify it for K equals 3.72. Okay, there you go. So that half-life definitely occurred during some point of the first month, because at the end of the first month, it was way less than half the weight. So the half-life has absolutely occurred during that time period. And so we get W of 1 of 9500 e to the negative 3.72 roughly equals, what was it, like 30, was it? Or 300? 230. 230. Therefore, accept. So that implies that A is equal to 9500, K is equal to 3.72. Again, marks here, you're going to be distributed. You're going to get recognize this information, find your value for A, so that kind of bangs off that mark there. Okay, again, this is worth 6 marks. So you get that. You get a mark for recognizing that you're going to be using the rate. You get a mark for correctly solving this K value there. You get a mark for rejecting this value here. And you get a mark for okay, and you're going to get a logical mark here, just to see if your workflow has made good sense. Next question, simple, familiar, worth 3 marks. I'm saying it's going to be take about 5 minutes just because you've got to read the question and actually understand what's going on. A little bit of trigonometry. Let's pause and try it. So we've got point A. Let's zoom in here. Point A is at sea level, and the angle of elevation to the top of some building is 35, that's a bit off, 35 degrees. 35 degrees. At the end of a 350 meter path leading directly towards the building, the angle of elevation to the top of that building is 60 degrees. So you go along here, along this path, and that's 60 meters above water level. So you haven't walked per tangent to water level. You've been on an incline. So you've got here you're 60 meters above now, where the angle of elevation here is now going to be 60 degrees, and that was a 350 meter long path there. And we will determine what is the height of this building. Okay, so let's scaffold some things out. We've got a big triangle here. Okay, we've got a big triangle. Okay, I'm going to call this distance left there x, and this value here is going to be the square root of 350 squared plus 60 squared. And I'm just going to quickly work that out. Is 355.1. So this distance here is 355.1 plus x, where x is the remaining distance to the bottom if you're considering it tangent along the ground, and that's got a height of h. And this I don't know. I don't necessarily care. And then we've got a shorter triangle here. Right there. Yes, we do. Oh, well, this is h minus 60. 60 degrees there. That's x there. Okay, let's come up with some simultaneous equations. So we're going to use number 1 here and number 2 there. So from number 1, we can deduce using tan. So we'd say tan of 35 degrees is equal to opposite, which is h, divided by this 355.1 plus x. And then using number 2, we've got tan of 60 degrees is equal to h minus 60 over x. I'm just going to rearrange here and solve for x using this guy here. So I've got x equals h minus 60 over tan of 60 degrees there. That way I can sub this into equation number 1. So what I'm going to have now, which produces tan of 35 degrees equals h over 355.1 plus x, which is plus h minus 60 over tan of 60. And I'm just going to plug that into solvent. Alright, so make sure that you are in degrees, because we're dealing with degrees here. You're going to plug into solvent, and the answer for h is going to pop out. 376.66 meters. So h equals 376.66 meters. Very cool. Again, here you're going to get a mark for coming up with these equations here, or some expression. You're going to get a mark for solving for h. And again, you're going to get some sort of a logic mark here for showing exactly how you're getting these equations, like where they're coming from. So that's 3 marks there. Question 14, this is simple and complex. We've got a little bit of a mixture here. 6 marks. Try about 8 minutes, so pause it, see how you go. So you've got weight classification, small, medium to large of pineapples, harvested in Queensland, distributed in particular ratio. Represent the data from the sales. Cool. The weight of pineapples is normally distributed. The mean is 1050, and 860 is the 20th percentile. Okay, calculate the standard deviation. We can do that by relating a z-score, the mean, and a particular score. So I know that the 20th percentile, I can work out that z-score. So z is equal to inverse normal, because this implies, if I've got my bell curve here, the 20th percentile gives me the area being equal to 0.2, and that's going to occur when x is equal to 860. So what is that z-score? Well, we can find that out. If we normalize our data, we'd say tail equals left, because we're considering from the left to the right. Tail equals left, area equals 0.2. The standard deviation is 1, and the mean is 0, and that's going to give us something there. Negative 0.8416. Negative 0.8416. So go negative 0.8416 equals x, which is 860, minus standard deviation, which is 1050. Minus the mean over the standard deviation. Solve n there. And then I'm going to get a standard deviation, I'll pop out. Probably don't need to solve n, but I'm not really in a mood for solving equations right now. Especially tech active, you leverage the calculator. You come up with the expression, then you get your answer. You're not getting marks for algebra in this exam. So, if you can get away with it, don't waste time. All right, unless the question says use calculus or use this particular method of solving it, just come up with the answer. All right. Okay, 255.76. 255.76. So you're going to get a mark for correctly determining the standard deviation, and you're probably going to get a mark here for showing this Z score. Because you need to do that in order to calculate standard deviation. Determine the 85th percentile. This is just inverse normal because it's like where exactly, let me do this in a different color. 85th percentile is like this area here is 0.85. What is the X score up to that particular point? So we can do that. We can say X is equal to inverse normal. Tail equals left. Where our area equals 0.85. The mean is 1050. And now we've figured out the standard deviation, so we can sub it in, 255.76. And this inverse normal will tell us what's the exact score that comes up there with those parameters. So again, it's sort of just like there's a couple of functions that you just need to be comfortable going to and from with in your calculator. Like there's not many of them, but once you've got them down, you can just navigate it around really nicely. 227, wasn't it? 227? No, 255.76. 255.76. 1050. Okay, so 1315.08. 1315.08. The last part of this question says determine the probability that from a random sample of 30, so n equals 30, that at least 10 will be large. So now this is a binomial, x is now a binomial probability rather than a normally distributed probability because x is now equal to the number of larges. Now, they form a ratio where there is 4 larges out of every 10 pineapples because it's got the ratio 3, 3, 4. So for every 10 pineapples, 4 of them are large. So the probability that you're going to randomly select a large one is 40%, 4 out of 10. So that is 0.4. Now, if I'm determining the probability that at least 10 will be large, that is cumulative probability, where your lower is equal to 10, your upper is equal to 30, your n is equal to 30, and your probability of success is 0.4. So again, you're going to get a mark for laying out this information here. Okay, by the way, before you're going to get a mark for just getting the correct answer. Just 1 mark there. Okay, this is 6 mark questions. There's 1, 2, 3, 4. 1 mark for the expression here and 1 mark for your correct solution, which we put into our graphics calculator. Navigating this properly. Again, you can see I've already tripled up on most of the formulas, most of the calculator functions I'm going to be using. So this is binomial, BCD, where I've got a lower of 10 and upper of 30, from 30, and probability of success is 0.4. 0.8237. So the probability that x is greater than or equal to 10, I probably need to put that in, otherwise I'm not going to get that mark there. So I'd say the probability that x greater than or equal to 10 is equal to 0.82, what was it? 0.8237. Very good. So this is a complex familiar question here. You've got, you're given the distance formula. Okay, so it says, determine the coordinates on the trigonometric function sine of x that minimizes the distance to this particular point. So let's just get a little sketch of what's going on here. Sine oscillates between -1 and 1. You've got pi on 2 pi there, and then you've got 3 pi on 2, and the function does this. Okay, now the coordinates for 2, 4's a little bit after pi, 2's going to be all the way up there, and we've got this distance there, d, we're going to call distance. So pretty much, we're trying to figure out where does it sit on this graph? What coordinates, x, y? Well, what's nice about this is the fact that I know what the y value is equal to. The y value is sine of x. So you could rewrite these coordinates there as x, comma, sine of x, because whatever the x value is, the y value is going to be sine of that function, because it's just function in spits out the y value. So the y value is dependent on our x value. So we can rewrite y in terms of x just by using the function. Now if we want to determine the coordinates that minimize this, we have now got a nice equation for distance. So that distance is equal to the square root. Now I'm going to call this one 4, 2, x1. I'm just going to write it really clearly. x1 equal to 4, y1 equals 2, x2 equals x, y2 equals sine of x. Okay, those are my coordinates. So when I'm putting them in here, I've got x1, which is 4, minus x2, which is x squared, plus y1, which is 2, minus y2, which is sine of x, all that squared. Okay, and what I've actually got here is I've got a function in terms of x for the distance, which is very nice. What I'm going to do here, I'm not asked to do any methods of calculus. I'm going to see what does this function, this one here, what does this function look like? Where is it minimized? And state the exact x value that minimizes it, and that'll give me this exact x coordinate there. And then if I find that x, I can just put into the y, and bang, I've got the coordinates and that I can deal with there. So, let's write this expression properly. It's all that stuff squared, all that stuff squared. So what I'm going to do here is I'm just going to graph the function I've got here and go from there. Now, since I am graphing a trig function, let's go back into radians. So shift, setup, radians. Okay, now let's get back to graphing. So we've got our function was the square root of 4 minus x all squared plus y, which was 2, subtract sine of x all squared. Draw that. Let's get a bit of view window here, so let's just zoom out a smidge. About this point here. Okay, cool. Now I'm pretty much just going to draw that there. Doesn't have to be exact. This is d of x, and then I've got x here, goes up to 14. What were my y values? It went up to 7. And it goes down, it's got sort of like a minimum around that 2 mark there. And it goes like this. So my minimum is exactly going to be here. So I would G solve minimum. And I'm going to get an x and a y value there. And I've just got to interpret that. So G solve minimum right there. So x is 2.65, y is 2.04. So 2.65, 2.04. 2.65, 2.04. Now I've just got to interpret this here. Therefore, the minimum distance is 2.04 units, because the y value there on that function, that's the distance. So the distance that's minimized is 2.04 units at x equals 2.65, you could call that radians if you will. Now we're pretty much just going to sub that back, so then we're going to go f of 2 point, or we might actually just go y equals sine of 2.65 in radians, evaluate that. And you're going to get 0.47. So you'd say the minimum distance is 2.04 units at the coordinates 2.65, 0.47. Very good. Okay, so this is worth 6 marks. So you're going to get a mark for coming up with the expression. You're going to get a mark for showing some illustration of what's going on there. Okay, that's our logic mark. You're going to get a mark for evaluating this y value. You're going to get a mark for stating the distance in words. You're going to get a mark for giving the coordinates. Okay, which then just gives you 1 mark left for coming up with that minimum. Now this mark, you're probably going to have to include a bit of a sketch here just to illustrate and some reasoning. So use gsolve to show that, yes, this minimum came because I put this function onto the graphing calculator stuff and it gave me a minimum. Okay, so that is our 6 marks there. Okay, this question here, it starts off simple, familiar. It's worth 10 marks. It's going to take about 15 minutes. I'm going to gloss over. I'll show you A, B, and then I'll show you C, just so you've got a moment to pause it. So you've got the attendance rate in economic lectures is modeled by a continuous random variable, or a PDF, where x is bounded between 0 and 100. So that is the percentage of attendance. Okay, f of x is the function, and that is the general form of it. So you want to determine the value of a, and then you want to determine the mean and the standard deviation. We can do that. That's our simple familiar stuff. Then the complex unfamiliar part is, from a sample of 40, determine the probability that at least 30% of students attend more than 80% of lectures. Pause it, give it a go. Okay, so if I'm determining the value of a here, I know that my PDF, the integral from 0 to 100 dx is equal to 1. Because it's a PDF, so the area under the curve is equal to 1. So it said the integral from 0 to 100 of capital A sine of pi x over 100 dx equals 1. And I'm going to solve n this. And I'm going to get an answer for A. So you're going to get a mark for giving your answer of A, and you're also going to get a mark for leveraging the fact that it's a PDF. So there's 2 marks there. Now, let me show you how to put this into your calculator. This is a nice trick. This is a very nice trick. So we go out of this. Make sure you are still in radians. Make sure you're in radians. Options, calc, solve n. And we're going the integral of this function here, alpha a. That's like our value that we're going to figure out. Right? Sine of, it was pi x over 100. So over 100. Yes. Close that bracket. From 0 to 100 equals 1. But we haven't defined this unknown variable yet. So just go comma a. And what you've put into your graphics calculator there is you've put in something to solve numerically, and you've defined that a is some unknown value. If you put in x, it's not going to do it properly, because it's just going to give you nothing, to be honest, because it's going to interpret it as a function, like x as an input to the function rather than x as a scalar to the function. So we solve in this, and this will take a little while, or not for me. Pi on 200. Pi, in blue, pi on 200. Okay, I can determine the mean using the formula sheet. This is a continuous random variable, so you're going to have 0 up to 100, and it's x times by your function. So you're going to have a, which is pi on 200, sine of pi x on 100 times by x dx, and that's going to give you your mean. Plug that into your calculator, you're going to get an answer. Okay, now when I'm putting this into my calculator, I will just show you this for a moment because I just tried to do it and it buggered up on me. It gave me definitely a wrong answer. So it's worth showing. So let's just put that in exactly how I wrote it. So pi on 200 sine of pi x over 100 and we're going to multiply that by x, right? That's exactly how I've put it in, from 0 up to 100 equals, and this is going to give me the wrong answer, or at least it did on my calculator right here. Yeah, it gives you the wrong answer. It definitely should not be. That is way too small. Something's gone wrong there. Okay, now for some reason, when I get rid of that and just put the x up here, as in I've got x times by this function, which is probably how I should be writing it, I get 50. And 50 is the correct answer. It makes sense because the mean value of a trigonometric function, it's like the average value, like logically speaking from 0 to 100, definitely should be 50. So the mean is equal to 50. Very good job. You're going to get a mark there. And I might rewrite this and just chuck the x there. Okay, the standard deviation is equal to the square root of the variance. Now the variance is equal to, and I'm just going to call this e of x for expected value, e of x. It's e of x squared subtract the square of the mean. So our variance here is going to be given by the integral from 0 to 100 of pi x squared over 200 sine of pi x over 100 dx, and then subtract 50 squared, and that's going to give us our variance. Okay, so I'm not going to waste any time here. I'm not going to bugger eyes around. I'm just going to chuck in, because it's the exact same thing here, so chuck in an x squared here. That's going to give me that stuff there. So 2973.58. 2973.58. Subtract 50 squared. That's going to give me my variance. And my standard deviation is going to be the square root of whatever that is there. So 2973.58 subtract 50 squared is 473.58. $21.76. So you're going to get, what are we going to get here? You're going to get a mark for calculating the mean. You're going to get a mark for this expression there, and you're going to get, well, actually you're going to get a probably better off. You're going to get a mark for the variance, and then to convert it to a standard deviation, you get a mark for that. Okay, so therefore, so far that's 5 out of the 10 marks here. So this complex unfamiliar component of this question is worth 5 marks. So just to remind ourselves, the PDF was A, which is pi on 200, sine of pi x over 100 for x being attendance being bound between 0 and 100. So it says, from a random sample of 40 students, determine the probability that at least 30% of students attend more than 80% of lectures. Now, since this is a sample, it's implying a binomial distribution. So x is now going to be a binomial distribution where n is equal to 40. And I'm going to define what x is. X is the number of students attending more than 80%, where P is going to be given by some area under the curve of our PDF, which is the integral from 80 to 100, because you could attend more than 80%, so that's going to be that there, which is pi on 200 sine of pi x over 100 dx, which sort of makes sense, because if this is your PDF sine function like that, 80 to 100% of people is going to be that area underneath the curve there, which should be a minority, which is 0.0955. Okay, and 30% of students, well, 30% of 40, let's just work that out, 40 times 0.3 is 12 students. Okay, so let's write this as a probability. So the probability that x is greater than or equal to, so at least 30%, x is greater than or equal to 12 is equal to the probability, so the probability that x is greater than or equal to 12 is binomial, where you start with the lower amount being 12, the upper amount being 40, the probability of that success being 0.0955, and n being 40. Just a little, like, you can put that in your calculator, you're going to get your answer. Just a little bit of interpreting with what's going on with this, right, is that you're picking 40 kids at random, and you want to know who's going to. So just a little bit of explaining here. You could put this in your calculator, but you want to know the probability that at least 30% of those kids, that's 12 or more, are going to go to more than 80% of lectures. So you're randomly going to pick out a kid, and there's a 9.55% chance that they are going to be attending more than 80% of the time. So intuitively, you should get a really, really small number here. Okay, the odds should be slim, even though you'd think logically that there should be a lot more. You put this into your calculator, BCD, low is 12, up is 40, 40 trials, 0.0955, and you're going to get the probability 0.000245, which is not a lot, those are pretty slim chances. That's like less than, those are pretty slim chances. Okay, so our 5 marks here. You're going to get a mark for recognizing that you're now dealing with a binomial probability. You're going to get a mark for determining the probability of success. You're going to get a mark for this expression here. You're going to get a mark for working through and getting the correct probability. And you're going to get a mark for identifying that 30% of kids is, in fact, going to be 12 of them in this sample. So there's your 5 marks there. So this one is a simple familiar to trigonometry question, a bit of 3D trig. So pause it, give it a go, 8 minutes, see how you go. Okay, so this question here, this is trig in 3D. So I've got a bit of north, south, east, west action happening here from point 0. You've got a building standing 95 meters high, is positioned at north, 55 east. So you go around 55 degrees there, you get this building, and it is 95 meters high there. And so if you can imagine, you've got a 2-dimensional triangular plane there. It's actually right angle triangle. A 14 meter tree is positioned south 20 degrees east. So you're going to have 20 degrees there, 14 meters high, not very high at all, 14 meters there. And again, that one is perpendicular, if you can imagine, to that point O. And they're saying both are perpendicular, yep. So from point O, the angle of elevation to the top of the tree is 35. So if you can imagine here, like from this point and that there, 35 degrees. And the angle of depression from the top of the tree down here is 32. So if you go in the backwards way of angle of depression, 90 minus 32, you're going to have 58 degrees in that little plane there. Right. So we want to determine the distance. Okay, let's just draw out here. We're going to have this triangle here. So we've got one on the 2D plane there. That's distance there. Well, let's just draw out this triangle here. So we've got point O. That's where the tree is, and this is where the building is. And you've got this there. Okay, well, we know that that is 90 degrees in there, so you're going to have This is going to be an extra, what is that, 55? So you've got 35 degrees left in there. And if that's 20 in there, then you've got another 70 degrees in there. If you add those together, you're going to get 105 degrees there for that angle. We're asked to find this distance. We're trying to find that. We can work out, I'm going to call this A and I'm going to call this B by using our two-dimensional triangle. So if I'm working the value of A here from this guy there, what I'm going to get is 10 of my angle is 35 degrees. That is the angle of my 2D plane that shoots out there, this one here, 35 degrees, is equal to opposite, which is 95 meter high building, divided by the distance it is to the base, which I'm going to call A, which is what I've already called it. Now I can solve that there. Make sure you are in degrees when you are solving this. Okay, and that's going to be 135.7 meters away. So this is 135.7. And then we can do the same thing for B. So tan of 58 degrees is equal to opposite, which is 14 divided by adjacent. In this case here, is going to be that distance there. So that's going to be my B distance happening down there. Again, let's just solve that. Okay, 8.75 meters there. So now if I'm working, and obviously this is absolutely not drawn to scale there. So I can say now this distance, d squared, is equal to 8.75 squared plus 135.7 squared. Subtract 2 outside of 8.75, outside of 135.7, cos of 135 degrees. Oh, sorry, of 105 degrees. Solve n. Can you get 138.2 meters? Okay, well that's going to be my answer there. So you get 5 marks here. You're going to get a mark here. This is a logic mark showing you scaffolding. You get a mark for working out the value of A. You get a mark for working out the value of B. You get a mark for that expression. You get a mark for the correct answer. 5 marks there. So these are tricky to prepare for because they're unfamiliar. I don't know what they're going to look like. So I'm just kind of like making up, anticipating, if you will, some of the stuff that they could throw. But like this is like probability pretty low of being on your anything like this being on the exam. So take it with a bit of a grain of salt. Now, you're going to get some information. This is telling us the surface area for a solid revolution is given by a particular formula. Now, you can use this formula if you're just applying your derivatives and you've got a graphics calculator to help you with the integration, right? So, like, if you can imagine the surface area or like how much area it is to paint that particular 3D paraboloid is given by that expression for the integral. Now, a paraboloid is a three-dimensional revolution constructed by, if you take a parabola and you rotate it about an axis, that's going to give you a three-dimensional shape. Okay, that's our information. A satellite dish is in the shape of a paraboloid formed by rotating the curve y equals ax squared about the y-axis and is manufactured with a diameter of 4 meters and a depth of 1 meter. We want to firstly determine the value of A, and then we want to get the surface area of the satellite dish. Pause it and give it a go. That's all our information there. Okay, so this here, we're going to rotate our parabola about the y-axis. That's this one here. So we're going to have a parabola. Looks like this. Y equals ax squared. Okay, where we want it to have a diameter of 4 meters. So that means the halfway point there is going to be 2, right? Because you're going to rotate it the whole way around. So rotating it halfway around is going to give you 2 meters. Very good. And a depth of 1 meter. So that means this is going to be 1 meter because from the bottom of the satellite dish to the top, 1 meter. So that means we've got a coordinate here that's x being equal to 2, y being equal to 1. Now we can rearrange and solve this because now we've got some stuff. We've got 2 is equal to a, a is 1, y is 1. 1 equals a outside of 2 squared. So a is equal to a quarter. Very good. You're going to get a mark for getting a correct answer, and you're going to get a mark for showing some information there. So that's like an info mark, and that is a correct value mark. Determine the surface area of the satellite dish. So I'm told that the surface area, S, is equal to the integral from A to B. In this case here, it's going to be from 0 to 2 of 2 pi x inside the integral of 1 minus dy dx, square that, dx. Okay, a couple of things here. We've recognized well actually I might just keep it general here. This is A and this is B. So we've recognized that A is equal to 0 and B is equal to 2 because that is like the total distance along my x here from 0 to 2. And my dy dx is going to be the derivative of my function, which is a quarter x squared. So it's going to give me 2 times that, so you're going to get a half x. Right, so let's just shovel this into our expression here. I've got s is equal to the integral from 0 to 2 of 2 pi x inside the square root of 1 minus x on 2 squared dx. Graphics calculator to evaluate this integral. Okay, and you get s is equal to 8.377 units squared. Okay, well, we've got 4 marks to distribute here, so you're going to get a mark for your bounds, a mark for your derivative, a mark for putting in the correct expression, and a mark for getting the correct answer. All done.